So, hi everyone. We're here today and we are going to talk about again platform engineering. Today I am not alone, and here Maximilian is with me. So let's introduce ourselves. Would I say, Max?
Yeah, hello, I'm Maximilian Marschall. I'm from Austria, working with evoila for a few years now, and I'm focusing on Kubernetes and platform engineering and all the little bits and pieces around it.
Right, that sounds fantastic. For those who don't know me, Marco Di Martino, I'm leading the business unit Cloud Native, and we have introduced the topic last time. We're going to have this series about platform engineering, and today we would like to dive deeply into the topic. So talking about what is exactly platform engineering, what are the main components, what should I focus on when I try to create my own platform, and all these topics. So happy to be here, Max. I would just start with the first question that we have in mind. So what is exactly platform engineering? How would you describe that?
Yeah, so platform engineering is a kind of philosophy. So it's more than just a product. There is different stuff like, for example, DevOps or site reliability engineering, which has its own topics. For example, DevOps is about the culture and how you work between dev and ops and how you share responsibility. Site reliability engineering, on the other hand, would be more about the production and making services available and keeping infrastructure running. And with the platform engineering, the target is to have a good developer experience and to ship software faster. And this keeps all of this together. So DevOps and SRE is also part of platform engineering. And so it's a bit of a bigger scope.
Yeah, that sounds reasonable to me. And I think that one of the things that I have observed is that platform engineering, I would also say that it's kind of the model that enables this DevOps culture, especially when we're talking about enterprises company. Because what we know is that if you have a small organization that probably you're able to do DevOps, and that's fine. You have one or two developer teams and you can start, building your CI/CD pipeline and stuff like that. And that works pretty good, I would say. But if you go into kind of enterprise and the organization keeps growing, you have different organizational units, you have to take care, of compliance, security, and then you have different teams, different scopes. And I think that that's exactly the way, or just the point where DevOps is not enough, and that's why we've been seeing it failing at some customers. And here is where I would say that platform engineering can deliver the difference, right?
Absolutely.
Yeah, which problems does platform engineering in concrete, concretely solve?
Platform engineering helps with rolling out security standards, for example, because we have automation and standardization as big important things in platform engineering. So it helps us to keep standardized and go away from project-based setups more into the direction of product-focused setups.
That's very interesting. What do you exactly mean about that?
For a project, or if you're project focused, you may create a new CI/CD pipeline for every new software project you have, and then you build it, and then you have to update it, and you have to manage this CI pipeline for this single project. And when you're finished and you start with a new project, you build another CI pipeline and all the things and pieces around it. And with product version, you would build parts that you can reuse. So not only like the CI pipelines, but maybe also some internal libraries and stuff like that. Because most of our customers, or what we've seen at most of our customers, is that they could reuse a lot of stuff they built in one project in another project if they would have made products out of this.
That's why I think many companies and the community especially is starting talking about this composability kind of thing, where you have like multiple components of the platform that you just can combine all together and build this kind of a product mindset. And yeah, I think that's really interesting. And I would also say that the shift into the mentality, where you're saying, you know, the switch from project mindset into a product mindset. When we talk about product mindset, you don't really have like a fixed scope. So is that true in your view, that building a platform is like, maybe you have some MVPs, maybe you start defining your goals, and that's totally fine, but you don't really have like the end. So like a platform is self-evolutioning kind of thing during the time. Does that make sense?
Yes, partly. So you should have a strategy to know where you want to go. That's really important, but you can't expect to have a fully fledged platform from the beginning. That's not how it works, because you need to build it in a direction you want to have it, and where your teams can be as productive as possible. There's maybe a little fact out there that we can have like up to 70% developer productivity increase, because they don't have to focus on how to deploy stuff, how to build stuff, and so on, and reduce duplicate code because we can reuse it with a standardized way. So that's the thing. You should have a general plan on where you want to go, but it builds over time. The most important thing from the start is a mix from automation and standardization. So automation is the crucial part and the most important one. So you can stay away from manual steps that produces errors, and also drift from the standard. But to be able to automate stuff, you need to standardize stuff, because you can't automate unicorns.
And that's also, I think, where problem starts to come into, right? Because what I think personally is just, if you try to automate something, and you already have a process and you just want to automate it, then we're talking about just technology, implementation of some, CI/CD pipelines or GitOps principles, Argo CD, and all that stuff. But when you have to standardize processes across different organizational units within your company, then is, I think, where problem starts to come into, because you have to agree on multiple things, you have to align with different teams, you have to, maybe also try to understand where you can say, okay, that's fine, we go into this kind of agreement between development and infrastructure teams. So I think that's also one of the most important things that platform engineering is trying to addressing. It's like solving this problem on a broader point of view, and solving also these organizational problems. Yes. Is that what you're also seeing in customer projects?
Yes, so it's important to zoom out a bit, and don't have only a focus on one team or one project, but broader than that. And another thing which is really important is when you start to standardize, you should not just standardize or automate the thing that you already have because you have it, but maybe also think about if it's the correct thing to do in future.
Yeah, absolutely makes sense for me. So I think we are already addressing it a little bit, but the actual difference between platform engineering, DevOps, SRE, I mean, we have talked about a little bit, but how would you define? So is there a real difference, or are we just inventing a new name for talking about DevOps and all that stuff?
So I would say there is a big difference, because as I already said, there is SRE and DevOps, which have their scopes, and platform engineering is just on another level, because it keeps in mind all of this stuff and puts it very close together. So yes, DevOps, the cultural part of DevOps is part of platform engineering, but on a different level than only doing DevOps, because you take a lot of the ops away from the dev again, because in the end our target with a platform is most of the times that we have a developer that doesn't need to leave his IDE and his Git commands to deploy stuff. And that's not something you reach with only DevOps. And platform engineering also helps us to get reliable services and to get a high availability through observability. So not only monitoring, but also observability. To forecast growth, for example, to be able to scale out before we have performance issues and stuff like that, and also to trace and fix bugs faster. So that would be a thing that an SRE would do, but it's way more efficient if it's done in the whole scope, because then you can really easily integrate the infrastructure and all the metrics you gather from there with all the traces you can get from the application level. And that's the great thing, because it's all integrated, and you should have a dedicated team for that to take care of your platform and not only silos.
Yeah, I think there were a lot of concepts that you were trying to bring into. So maybe we can try to put a little bit of order, because so one very important thing you were saying, you were talking about observability, and that's not just monitoring. Maybe we can have another session on what's observability, because I think it's a very interesting topic. But stay away from that. I think that, so you were also saying that DevOps, SREs, this kind of silos mentality, we should try to get rid of that. And you were mentioning a dedicated team. So that's something that I see as, like, it's essential if you're trying to establish a platform culture in your organization. What does it mean to have a dedicated team?
So it doesn't need to be a whole team just taking care of the platform and all of the people do the same, but it has to be a team working closely together, focusing on the different parts of platform engineering. And what's also really important is you need somebody or some people that have like the overview about all this stuff, and always keep in mind the experience, the user experience or developer experience.
Exactly.
That's really important, because the most important thing for the platform is that the user, so the developer, is happy with it, or else he won't use it.
So are we saying that we should try to sell our platform to our customers?
Probably, yes.
Yeah.
So you need to do some, that's more organizational, less technical, but you need to do some like marketing for your platform internally, and promote it and have good documentation, stuff like that.
Yeah, I think that's why it's, I think, also very essential for kind of a platform team to have a strong product management. So I see it that way. When you're talking about platform engineering, probably you can try to define it as having a dedicated product team or platform team, whatever you can call it, having a centric design that is addressing the user experience. So we build a platform for our developers. We don't build a platform for ourselves. That's not very interesting. I mean, technically it could be, but maybe you're not addressing the business outcome. And the third thing is you need to have a very strong product management, because as you were saying, you kind of have to, do a little bit of marketing and try to sell the platform. And I think maybe we have a question on that, but if not, that's not a problem. Is that a big problem in the kind of a project where you're working, is like trying to build something and then you get like developers not wanting to use the platform? And why is that?
So I've definitely seen platforms where developer didn't want to use it, and the problems are more or less always the same, which is not listening to feedback and not adapting fast enough. So if you only try to do platform engineering with one team and expect the whole company to be happy because this team was happy, that's not how it works, because all the people are a bit different, and maybe team A is super happy, but B and C do something completely different and they can't work with the platform. So you need to be always gathering feedback. So that's a non-stop process, and so the platform will never be finished because there will always be feedback which you need to listen on and adapt.
Very, very interesting. Another thing that we maybe can talk about a little bit is which are the main components that belong to a platform? Because now we've talked about what is platform engineering, why it helps, why it's so important for enterprises, and how you should see this as a product with dedicated platform team and all that stuff. But so zooming a little bit into the component world, so like how should we build that kind of platform? What are the components?
So one really important component is the infrastructure it's running on. So
makes sense.
It needs something to run on. So this can be mostly it is Kubernetes these days. This can be on-prem. This could be in a cloud. Doesn't really matter for the platform. Then you would need some kind of automated deployment process for automation. These days we use GitOps for that, and maybe some CI pipelines to automate stuff.
Very briefly describe GitOps.
Yeah, so GitOps is a principle where we have the single source of truth in a Git repository and some kind of reconciler that keeps our infrastructure in sync with the Git repository, so we can administer our complete infrastructure via Git commits and have some history and a single source of truth. That's the most important.
And that also can be used from the development teams to exactly do the same deployment of the workloads.
So that's what I was referring for before. The developer shouldn't need to leave his repository to change stuff.
Yeah.
So that's where GitOps comes in handy. So the infrastructure part, mostly Kubernetes, then the GitOps part, and then another really important thing is observability in the platform, deeply integrated, and then some kind of self-service. There is multiple ways to do this. This can be an internal developer platform, so maybe a web interface for your developers to have self-service, but it could also be just managed over Git if your developers are happy to use that, and just open a pull request to do stuff instead of a ticket or instead of some web frontend. So that's the most important things.
Yeah, and I think that you were mentioning self-service. Maybe we can, try to better explain what exactly do we mean with self-service. Because I think if you were saying that you have a platform or you build a platform and you don't really have self-service, I would argue that you haven't really a platform.
Yes.
Can we say that?
Yes, a platform without self-service is no platform. Not in the platform engineering mindset. And for the self-service, we need to have stuff, for example, like creating a new repository for a new project. And with that, we need to have automatically created some kind of deployment process and deploying this application to some maybe development cluster, or also maybe already the staging process in the direction of production. And all this should be able to be handled without a ticket where somebody needs to click through or create a user or whatever. So that's the part of self-service. And that's also why developers love this, because they don't have to wait for 2 weeks to get a new virtual machine or whatever. They just click on it and it happens, because nobody needs to interfere there.
Yeah, like a magic. So there is this big engine, which is the platform that does kind of everything for you, and you don't need to talk to, I don't know, many people, wait different days to just have a Kubernetes cluster up and running. That just seems reasonable to me. Yeah. And also another thing that is kind of interesting, so I would say platform engineering is based on two main models. The self-service is one model, and then you have the shared responsibility model, which I think we were talking about a little bit at the beginning. But so this shared responsibility, I think it's very difficult to kind of really understand, like in practical, where and how can you implement that? So do you have something in mind, kind of examples? Because, for example, what I see it is, let's say I'm a developer, and let's say you have a portal where I can just use self-services, and I need a database for my application, and I can create, or let's say I can order a database through the self-service. But what if I want to have some configurations and some freedom to do what I want, but not 100%. So where do we draw the line there? Because I think that's this shared responsibility, right?
Yeah, that's definitely the shared responsibility, and that's a big challenge. And I must confess there is no answer, because there is many right answers, many correct answers, because it totally depends on your company and your team, on where you have to draw the line. There is developers that never touched a container, for example, and if the target platform is a container platform, then they need to have the line drawn with their code. So they write code, and everything after that is none of their business, because that's not something they want to tackle. But if you have developers that are working with containers and Kubernetes, for example, for years, then they maybe want to have access to a Kubernetes cluster and manage the deployments on their own, to do whatever with it. Then it can also be drawn at the clusters level. For example, the developer can order his own Kubernetes cluster with just the baselining. So, for example, security and logging and observability should always be part of the platform. But it's fine if a developer wants to deploy their own on the cluster, if your platform can support it.
Yeah, that sounds very interesting. All right. Oh, yeah, I mean, you've been talking about security, observability. When can we say that you have a good enough platform? So what are the things where you will say, look, if you try to build a platform, you have been doing this and this and that you probably have a good baseline, at least?
Okay, that's really a hard question. I would say there's the 80-20 rule. So if 80% of your projects or products and teams can work with the platform without any problems and friction, then it's a pretty good platform. So there won't be a platform in a big enterprise that fits 100% of the needs. That's just not possible to do in a realistic standpoint. But 80-20 is a good rule of thumb, and if you keep on improving, you can also get higher numbers. But I think 80-20 is pretty good. And yeah, so the most important thing to measure the success of your platform is the adoption of your developers and also the experience. So, as I already said multiple times, feedback.
Yeah.
If the feedback is good and you have a high adoption rate, you have a good platform.
I think it's a very, very important point, because what we have seen also in the past is like, you are trying to build a platform, you're trying doing stuff, rolling out Kubernetes, rolling out CI/CD pipeline, create some self-services that you can expose to the outside, to your developers, to your customer, whatever it looks like. And then when you think that you are done, then you start looking into the adoption. So you start measuring, okay, are people using our platform? And then you start realizing, no, they won't adopt the platform because that's not what they want. We have different things that we should have done in different shapes and different technologies, maybe whatever it is. And I think there is like these lean methodologies that can help you to have like short feedback cycles where you can just look at what you have done and try to, looking internally, is that exactly what we wanted to achieve? Are we going into the right direction, or are we trying to build something that probably no one is going to adopt? So I think that's a very important topic. Talking about adoption, platform adoption, marketing internally, building this strong baseline. I mean, all these things that we have said, in my opinion, they kind of share the prerequisite that we should have a strategy. or can we just go blind and let's do Kubernetes, let's try to implement some backstage things or Argo CD, or how do you see that? Do I really need to have a strategy?
You need to have some kind of strategy. As I already said, you can start little and only have few things implemented in your platform, but you need to have a big vision on where you want to go, because running around like a headless chicken doesn't work
very well.
Very well, yeah.
All right. Maybe one thing from the point of view of let's say what you're doing right now in your role as a consulting engineer, what would you say is the general understanding of platform engineering? The thing that you see at customers, not to see around the community, because there we know that there's a lot of experts and a lot of things going on actually. But how do you see generally from customer point of view, let's say?
Most of the people I've met at the customer side still think about infrastructure when they hear the topic platform, because platform always was infrastructure, and so that's one thing. And the other thing is that a lot of companies don't really understand that they need dedicated people to take care about it, because for now all the CI pipelines were managed by some developer that one time built them, and now he's managing it for the last 5 years, which worked out for this setup. But if you really want to take platform engineering serious, you need to have people focusing on that.
Yeah. Last topic that came right now into my mind is also the investment, right? I think it's a very big topic. Like, we need to invest into this platform, but we don't really know how it will work out. So it's kind of a risk to say, should we do that, or should we just stay with infrastructure and development and security, or should we go into that direction of building this build platform as a product? I think the investment part is also very important, and I think that's why you need a clear strategy on how you build the platform, because otherwise it won't work. Do you have some thoughts on that?
I think the upfront investment, it's definitely there, but as already mentioned, the developer productivity can spike really high if the developer doesn't have to take care about missing virtual machines or updating stuff, or managing CI pipelines and managing failed build servers or whatever, and also, for example, optimizing CI pipelines. Because if you have a platform engineer focused on the platform, they can optimize CI pipelines. I, for example, have a customer where we had CI pipelines running for multiple hours, and if you can cut down the CI pipeline from running multiple hours to some minutes, because you don't really need to have a full build all the time, because you only changed a few components, then you can save a lot of time for the developer and also for testing, because you can iterate faster.
And time is equal money, right?
Time is money, yeah. And also we all want to fail fast to be able to fix fast.
Yeah, exactly. Yeah, I think there could be another topic, but maybe we will do a deep dive session on that, because I think we have a lot of opinions on that. In the investment part, you could also start talking about, should I invest in a big product and then kind of being satisfied with the vendor solution, let's say, or should I do it yourself? So building the platform, use maybe some open source technologies. Maybe it's just a mix of both things, but I think that it's fine for today. We can cover it in another session. So yeah, that's it from my side. Max, thank you very much.
Thank you, Marco.
Yeah, so
it was a pleasure.
See you next time.
See you.